Good morning, everyone. I hope you are doing well again. Today we are back with another question that has been taken from the book that is Mathematical Analysis, written by S.C.Malik and Savita Arora. And in this question, it is asked to find out the limit of the following term. Let me read out the question for you. Limit n tends to infinity 1 by n plus 1 into n plus 2 continue up to n plus n whole to the power 1 by n. Now, to approach this question, this is very easy. We'll be using some of the theorems and the general principles and get the results. Now let's begin with it. Now first of all, we have to find out the unth term. Definitely this term is given in this term is the unth term. Now let me rewrite the term so that it will be easy to solve. Okay, now we can write unth term is equal to 1 by n into n plus 1 n plus 2 n plus n whole to the power 1 by n. One thing we can do that we can take this and inside this term, how we will be taking this? We can rewrite this equation like this: n plus 1 into n plus 2 n plus n. So sorry, this will be unth to the power 1 by n. Okay, this will be equation will be unth to the power 1 by n. Now how to we will be writing this like this: n to the power n whole to the power 1 by n. Now you see that this term, these terms, this series has come in this form. Okay, now let's deduce unth term. We can write unth term will be equal to n plus 1 into n plus 2 into n plus n by n to the power n. Now what will be un plus 1 term? Unth plus 1 term, and why we are taking unth plus 1 term? I will be showing you a theorem so that it will be clear. So unth 1 term will be this one. I hope this is clear. We have done nothing. We have just replaced and added one of the term, that is n plus 1 term. Okay. Now we have got a theorem which I am showing you on the screen, and by using this theorem we will be finding out the limit of this sequence. Okay, now so limit n tends to infinity un plus 1 by un. You can pause the video and see the theorem what it states. By this theorem the getting the answer will be quite easy. So let's find out un plus 1 by unth term. This will be equal to n plus 1 into n plus 2 multiplied n plus n plus n plus 1. What we are doing, we are just substituting and we will be calculating the values. That's it. Now unth is in the denominator, so it will be reversed form. So I have written this. Now what do you see? What do you see? These if you see that, if you see this, that m plus n terms up to m plus n it's same. Let's cut out these terms. Now this will be equal to how much? N to the power n by m plus n plus 1 by n plus 1 to the power n plus 1. Okay, everybody got the point? Okay, now let's take out n to the power n common from this. N to the power n plus 1. Now n to the power n 1 plus 1 by n into n plus 1. Okay, I hope I'm clear. Now here n plus 1 will be coming. Okay, so this is the value. Now again let's take one n from common from this. This will be n to the power n plus 1 by n to the power n plus 1. From here we have taken out n common, so m by n plus 1 plus 1 by n. Okay, now this will be 1 plus 1 by n plus 1. Let's cut this down. Okay, now can you see we have got this? Okay, now what we will be doing, it's very simple. Again, take 1 plus n common. Let's take 1 plus n common, or let's separate it. So this will be n by 1 plus 1 by n to the power n plus 1. Okay, plus this will be 1 by 1 plus 1 by n to the power n. This term is separated, what we see that it will come down, then it will become minus 1 and 1 plus 1 by n to the power n we will be getting. Now by the algebra of limits, we know that if an, bn are two sequences, and if limit an plus bn is there, so limit an plus bn will be equal to a plus b, where an tends to a and bn tends to b. So same here, applying the algebra of limits, we will be getting, if n tends to, limit n tends to infinity, un plus 1 by n un. Now as this term tends to infinity, this complete will be equal to 0. This complete will be equal to 0 because n is here. If n tends to infinity, definitely it will tends to 0. But here, if n tends to infinity, we have a formula. What formula we have? We have a formula that limit n tends to infinity for 1 plus 1 by n to the power n is equal to e. And if limit n tends to infinity, that is 1 by 1 plus 1 by n, this will be equal to 1 by e. So by using this, we can general term, we can say that this is equal to 1 by e. Okay, so the answer that we got for this question is equal to how much? It's equal to 1 by e. So that's all for today's, guys. If you like this video, then please like, share and subscribe to my channel. And if you have any doubt regarding your any mathematics term problems, then you can send me the email ID that I give below. Thank you. Till then, be safe, stay at home. Thank you.